Hi, good evening, friends. Good evening to all of you, and welcome back once again on the YouTube channel of BYJU'S Exam Prep. Can you please quickly confirm if I am audible and visible to all of you? So, friends, can you please all quickly confirm if I'm audible and visible to all of you? Already, a lot of students are there. Good evening, everyone. Hello, everyone. Hello. All right, so here I am. I'm live in front of you. So, friends, welcome back once again on the YouTube channel of BYJU'S Exam Prep. I am Gaurav Gupta, and today I welcome all of you to our next session in the last lab to CAT 2022 Geometry Essentials. Now, today we are going to cover all the concepts of geometry, all the most important concepts of geometry, with some of the questions that will clear most of your concepts, and these can be some of the most probable questions that may appear in front of you in the upcoming examination. So friends, I hope that you are revising all these things properly in this festive season. I understand that most of you might not would like to study, but yes, Diwali is over now. It's very important, it is essential for all of you to put your complete focus towards your preparation of CAT. Starting today, we have exactly 1 month left for CAT, and exactly 1 month after today's date, we'll have to sit for this one of the most biggest examination of our lives. So friends, Varun, thank you very much. Diwali was good, and I hope the same thing for all of you. All right. And yes, exactly, music core. Only 1 month is left for CAT, and since like I just mentioned that Diwali is over, now we need to shift our complete focus towards the preparation of CAT. Now, previously in this series, we have already done a lot of sessions, and I believe all of you must have watched these sessions and must be preparing in parallel to all these sessions. Now, today we are going to cover some of the important concepts and the questions on geometry. So the name of the session, Geometry Essentials, in the last lab to CAT 2022 series. I welcome once again to all of you. Okay, now let's have a look at some very important facts related to geometry and how this topic has behaved in the previous year papers of CAT, and what is the importance of geometry. All right, so weightage in CAT of this specific area, which comes in quantitative aptitude, the name of the area is geometry, and you can easily find 4 to 5 questions, a minimum of 4 to 5 questions in your examinations. Sometimes we have even seen that geometry crossing 25% of the weightage in QA section of CAT. Yes. So like this year, we are expecting somewhere around 22 to 26 questions in QA section, though it is not yet clear how many questions will be there in QA section, but definitely you can see 5 questions from this area. Okay. Now, what all areas, what all topics are under geometry? Let us make it clear. So starting from lines, angles, triangles, polygons, and circles. So these are some of the most important areas under geometry from which there is a higher probability of questions appearing in your examination. Further, other than this, you may find questions on quadrilaterals, you may find questions on mensuration, that may be a 2-dimensional or a 3-dimensional geometry. All right. Further, after this, you may have some questions, 1 or 2 questions coming up from coordinate geometry as well. All right. Okay. Let me look at some of the things posted. So Karthik says, sir, how to cover basics of any topic if we are confused? Now, Karthik, if you are confused and you want to cover the basics of I believe these two are totally not related things. So if you are confused, then it is always better to start from the very basics of any of the topics. So what you can do is, if you are an aspirant for this year, then it might be a little late to start the basics at the moment. But if you are an aspirant for the next year, then you can pick any of the basic booklets. In case you are weak in mathematics, then you can pick up NCERT books of 7th, 8th, 9th and 10th. All right. Otherwise, you can refer to the notes that are provided by BYJU'S Exam Prep. And in our notes, we have explained each and every concept in detail. So you will not have any problem related to the basics, related to the foundation of the topics of any of the things that you have not covered yet. Okay. Ansari, yes. Okay. So you are thanking us for the video. No problem. I haven't covered geometry till now. Will this session be enough to cover? Guru Prasad, nothing is enough. If I'll say that after attending this session, you will be a champion of geometry. No, it is not like that. Now, this session is meant for the students who understand the basics of geometry, okay, and are sitting in this session just for a purpose of revision and solving some of the difficult questions, okay. So this session will definitely help, but this session will not be enough if you haven't started with the geometry. I'll be very transparent to you. All right. Okay. So friends, these are the areas that will come under geometry. All right. Now let's have a look at some of the very important formulas related to geometry. Now I'll be presenting some of the formulas. Obviously, I'll not be giving you detailed analysis of these formulas. This is just for the revision purposes. Okay. If I'll start explaining each and every formula, then it will take us 7 to 8 hours to finish the geometry. All right. We have this much time, but I want you to spend this much amount of time by yourself in understanding the basics of geometry. Now, starting with lines and angles, the first set of formulas. So, about the angles, we have two relations: complementary angles and supplementary angles. All right. Now, the angles whose sum is 90 degrees are called complementary angles. The angles whose sum is 180 degrees are called supplementary angles. All right. So this is complementary and supplementary angles. I'll be covering all the basics very quickly so that all of you will get warmed up and will be able to solve the questions that I have brought for you in like least possible amount of time. The next is, if there are n lines, there are a total of n lines in a plane, okay, and these are intersecting lines, then the maximum number of points at which they can intersect is given by this expression. So all of you keep noting down these values, these formulas. So n into n minus 1 upon 2, this can also be given as NC2 if you understand the formula of combination. So NC2 or n into n minus 1 upon 2, this will be the maximum number of points which will be generated by the intersection of n lines. Okay, and the total number of regions in which the entire plane is generated, okay, the total number of regions in which entire plane is divided is given by n into n plus 1 divided by 2 plus 1. So these are some of the important formulas that may be used directly in your examination. All right. Okay. Now moving ahead, looking at the next formula, if n non-collinear points are joined. So this is one of the formulas that you would have seen in permutation combination as well. So if n non-collinear points are joined, then the maximum number of lines that can be drawn among these non-collinear points is n into n minus 1 upon 2, or again this can be written as the formula of combination, that is NC2. Okay. Now moving ahead, the next is polygons, some important formulas. Now these are very important and can be used directly. Now sum of all the interior angles of a convex polygon. We are talking about convex polygon. Okay. So sum of all the interior angles of a convex polygon is given by n minus 2 multiplied by 180, where n is the number of sides. All right. Where n is the number of sides. Further going ahead, each internal angle of a regular convex polygon. Now earlier it was any convex polygon. Now in the second formula we have a regular convex polygon. A regular polygon is a polygon such that all the sides are equal and all interior angles are also equal. All right. So measure of each interior angle of a regular convex polygon. So the sum of all the angles n into n minus 2 into 180, picked it from first formula, and whole divided by n will give you the measure of each interior angle of a regular convex polygon. Okay. Now the next formula, sum of the exterior angles, no matter what is the number of sides. sum of the exterior angles of a convex polygon will always be 360. Doesn't need to be a regular polygon. Okay, so any convex polygon, the sum of all the exterior angles will always be 360 degrees, right? Okay, now moving ahead with polygons, each exterior angle, now if we consider a regular convex polygon, now since it is a regular polygon, all interior angles will be equal and hence all exterior angles will also be equal. Now measure of the sum of all exterior angles was 360 degrees. So measure of each angle will be 360 divided by n. All right. Okay. Now moving ahead, next formula, number of diagonals in a convex polygon. So it is given by n into n minus 3 divided by 2. Okay. Or you can write another formula in terms of combination nc2 minus n. So you can learn any of these formulas where n is the number of sides. So nc2 will be the total number of lines minus n minus the number of sides will give you the number of diagonals. Okay, so you can take any of these two formulas, both will work. It's totally up to you whichever formula you're comfortable with, and both will give you the same results definitely. Okay, now let's move ahead and look at some of the formulas related to triangles, the area of triangles. Now we have plenty of formulas for area of triangles. Depending upon what is given to you in the question, what information do you have in your hand, that will decide which formula for the area of triangle needs to be used. Okay, so let's look at some different formulas for area of triangles. Now number one, if we have a triangle in which all the three sides are given, generally we use this formula in a scalene triangle. Equilateral triangle, we have a separate formula. Isosceles triangle, we have a separate formula. So generally we use this for scalene triangles, but this formula can be used for any triangle if all the three sides are given. The name of the formula is the most important formula, the most famous formula, Heron's formula, and the formula is under root of s minus a, s minus b, s minus c, where a, b and c are the length of the sides and s is the semi-perimeter, which is given by this formula. Semi-perimeter means half of the perimeter, a plus b plus c divided by 2. All right. Okay, so this is the most important, most famous formula, the most used formula for the area of triangles. The next formula is for isosceles triangle. Now, you may or may not learn this formula. Okay, you may skip this formula as well, because not every time you're going to use this formula whenever an isosceles triangle is given. For an isosceles triangle, you can also use half into base into height, because the sides are given, you can calculate the height and then use that formula. Okay, but if you can learn the formulas, then it's better to save time and apply this formula. So for isosceles triangle, it is b by 4 under root of 4a square minus b square, where a refers to the equal sides, the two sides which are equal, and b refers to the base or the unequal side. Okay, now moving ahead, looking at the formula for equilateral triangle, simple, root 3 upon 4 side square. Okay, where a is the side of the triangle. Okay, no Vijay, I'm really sorry, PDF is not available for the students. I also don't have the PDF, but definitely I can provide you PDF of the formulas. Okay, so I can provide you the PDF of the formula, which will include the formula of geometry as well as some other topics. Okay, all right. Now moving ahead and looking at the next formula for area of triangles, if two sides and an included angle is given. So this is another formula used at a lot of places, half product of sides multiplied by sine of containing angle. All right. Next, for right angle triangle, or in case you are given the base and the perpendicular height, then you can use the formula half into base into height. Half into base into height is the most general formula for the area of triangles. All right. So half into base into height can be used in right angle triangle or any other triangle in which base as well as the perpendicular height to the base is given. So these are 5 formulas for area of triangles. Wait and watch for the some more formulas for area of triangles related to in radius and the circumradius. So we still have two more formulas to come for area of triangles. But before that, we'll take on triangles, some of the important properties of triangles. Now in a right angle triangle, sometimes we are given one of the sides and the angles, let's say 30, 60, 90 degree triangle here. Okay, and based on the given length of one of the sides, we need to find out the other sides. And we generally use trigonometric ratios, trigonometric formulas to find those other sides. That will consume somewhere around 10 to 15 seconds. Okay, but you can directly remember this ratio of the sides in a triangle having the angles 30, 60 and 90. Okay, so if we have a right angle triangle whose angles are 30, 60 and 90, then I can say that the sides opposite to 30 degree, 60 degree and 90 degrees respectively will be in the ratio 1:√3:2. So this will be the ratio. Out of these three numbers, 1 is the smallest number. So that will be the smallest side opposite to 30 degree angle. The next side is √3, that will be opposite to 60 degree, and the largest side will be opposite to 90 degree angle, and it will correspond to 2. So 1:√3:2 is the ratio of the sides opposite to the angles 30, 60 and 90 respectively. You can remember this. Okay. Another triangle that we generally see, another right angle triangle that we generally see is 45, 45 and 90 degree triangle. Okay, so in this case, the sides which are opposite to 45 degrees, they are 1:1, and the side which is opposite to 90 degree is √2. So 1:1:√2 is the ratio of the sides opposite to 45, 45 and 90 degree angles in a right angled triangle. All right. Okay. Now let's move ahead and look at the next thing in right angle triangle. Now if all the three sides are given in a right angle triangle, then the value of or the length of the in radius. What is in radius? In radius is the radius of in circle. What is in circle? In circle is a circle such that it is touching all the three sides of the triangle internally. Okay, a circle that can be drawn inside the triangle such that it is touching all the three sides of the triangle is called in circle. The radius of the circle is in radius. In a right angle triangle, you can directly write the value of in radius as a plus b minus c divided by 2, where a and b are the perpendicular sides. Make sure you are not making any mistake here, where a and b are the perpendicular sides and c is the hypotenuse. Okay. Moving ahead, looking at the next formula for the circumradius of a right angled triangle. So remember that in a right angled triangle, circumradius is always half the hypotenuse. Okay, so its length is half the length of the hypotenuse. All right, this happens in a right angled triangle only. Don't use this particular thing for any other triangle. Okay. All right, now let's move further and look at some of the very important geometric centers of the triangle. So geometric centers: centroid, circumcenter, incenter, and the orthocenter. So there are some relations based on these geometric centers that are very important and are tested directly in the examination. Now let's talk about centroid. Ab centroid hota kya hai? What is centroid? Centroid is the intersection point of something. Now what is this something? Centroid is the intersection point of the medians. Okay. Now median क्या होता है अब ये सब चीजें पता होनी चाहिए. You must know all these basic facts about triangle. Median is a line that divides the opposite side in two equal parts. So median is a line joining the vertex with the midpoint of the opposite side. Okay. So in a triangle, we can draw three medians, and all these three medians intersect at a common point, and this point is called centroid. Okay, right? Now, some properties related to centroid. The centroid divides each median. Okay, the centroid divides each median in the ratio 2:1. The portion 2 is towards the vertex and 1 is towards the side. Okay, so if you draw a triangle, draw all the three medians. They will definitely intersect at a common point. This common point is centroid, which divide all the three medians in the ratio 2:1. Okay, one very important thing. The next is Apollonius theorem related to centroids. Okay, now below I have drawn a triangle for your reference. Have a look at it. Okay, now in this triangle, I have drawn three medians. Now, first of all, consider only the median AF, the first formula. Okay, so AF is the median. Look at the sides on either side of this median, AB and AC. So AB square plus AC square is equal to, AB square plus AC square is equal to twice of median square. Median, I'm taking it as AF. Okay, plus BF square. So look at BF, or you could have taken CF because BF and CF are equal. Okay, so AB square plus AC square is equal to twice of median square, that is AF square, plus BF square. Now you can write the other two formulas yourself by considering the other two medians as well. All right, now this is Apollonius theorem, and the statement is very important, and it has been seen that this statement can be used as a shortcut in a lot of questions. Okay, now using Apollonius theorem, you can derive one wonderful result that says that sum of the squares of the three sides. So let's say the triangle has sides AB, BC and AC. So AB square plus BC square plus AC square. Okay, sum of the squares of the sides. I'll give you the formula in much better way. Okay, divided by sum of the squares of medians. AD square plus BE square plus CF square. So let's say these are the three medians. This ratio will always be 4:3 in every triangle. Okay, so sum of the squares of sides divided by sum of the squares of medians, the ratio will always be 4:3, and this particular relation is derived from Apollonius theorem only. Okay, now for you there is no need to derive this result. Okay, but if you want to strengthen your basics, strengthen your concepts of geometry, then do try and derive this relation using the statements of Apollonius. Okay, it will be useful for all of you. All right, fine. Now I'll take a pause for a few seconds. Okay, I'll take a pause for a few seconds, and let's see how many of you are still alive in this session. How many of you are still listening? How many of you are still enjoying this session? Come on. So quickly, all of you, those who are there in this session, quickly just write a yes in the chat box just to acknowledge that you are listening to each and everything that I'm explaining. Okay, so I want to see a yes, a small yes or a big yes. All of you, come on. Let's see how many of you are there. And if we have taken a small break, I want each and every one of you to quickly go back and like this session. So there are very less number of likes I can see in this session. I want all of you to increase the number of likes, and before this session is over, let's keep a target of 100 likes in this session. Okay. All right. So a lot of you are alive. Thank you for confirming, all of you. Okay, so let's continue this session further. Now the next thing is in center. So we have just seen centroid, which was the intersection point of medians. Let's talk about in center. Now in center is the intersection point of angle bisectors. Now angle bisector क्या होता है? Angle bisector is a line that bisects or divides equally the interior angle of a triangle. Okay, so we can draw three angle bisectors in a triangle, and these three angle bisectors will meet at a point, and this point is called in center. I have already told you what in center is. Okay, so you can relate. All right, so angle bisector theorem pehle kar lete hain, because in center is formed using angle bisectors. Okay, so internal angle bisector theorem. Okay, now if AD is the angle bisector in the triangle that you can see at the bottom of your screen. So AD is the angle bisector. So these two angles that I'm marking now will be equal. So according to angle bisector theorem, AB upon AC. So angle bisector, the sides on the either side of the angle bisector, we have to take their ratio. So AB upon AC, this will be equal to BD upon CD respectively. So AB upon AC will be equal to BD upon CD. All right. So this is the angle bisector theorem. Varun, yeah, thing is, Varun, you're asking how many questions come from Apollonius theorem. Now, Varun, you will not find questions coming from each and every topic of geometry because there are more than 100 concepts in geometry, and CAT doesn't even have a total of 100 questions including all the 3 sections. Okay, so if they will decide to make a question on Apollonius theorem, they may make one question on Apollonius theorem because this is one very small concept in one of the topics in geometry. All right. Okay. So let me continue. So this was angle bisector theorem. Now, next is the in radius of an in circle drawn in any triangle is given by. So how to find out in radius? So in radius is denoted by small r and it is equal to area of triangle divided by small s. A is the area of triangle and S is the semi-perimeter. So if you want to derive the in radius in any triangle, then you can use this formula, area divided by S. Now this gives us the next formula for area of triangles, that is area of triangle is equal to small r into small s. Small r is in radius and small s is the semi-perimeter of the triangle. Okay, so this is another formula that I was talking about using the in radius of a triangle. Okay. All right. Now moving ahead and looking at the next thing. Now this is a very important relation. So first of all, what I have done is I've taken triangle ABC. Look at the figure at the bottom of your screen. Taken triangle ABC. Okay. Now in this triangle ABC, I have drawn interior angle bisectors of angle B and angle C. Now they intersect, let's say at a point O. So these two angles are equal and this angle are equal. OB and OC are the angle bisectors of angle B and angle C. I've drawn the figure separately for all of you. Okay. All right. Now to find out this angle, angle BOC, you can use a direct relation. So angle BOC is given by 90 degrees plus half of angle A. All right. So angle BOC, the angle at the in center, we call it angle at the in center. Angle BOC is 90 plus half of angle A. Okay. All right. Now similarly, look at the next thing. I'll erase this figure. Okay. And we'll draw a new figure for all of you, a new relation. Now I'm drawing triangle ABC once again. AB is extended as well as AC is extended. Now you have exterior angles, exterior angle B and exterior angle C, and draw their bisectors. Okay, so now I'm drawing the exterior angle bisectors. All right, such that this part and this part is equal, this angle and this angle is equal. Now these angle bisectors, let's say, are meeting at point O dash. Okay, so angle BO-C, this angle that I have marked, can be given directly by the relation 90 degree minus half of angle A. So in the previous formula, it was 90 plus half of angle A. In this case, it is 90 minus half of angle A. So this formula can be used directly again in a lot of questions. Okay. Now, Anshrita is asking, sir, can you tell us something about your expectations, predictions, how the QA would be this time, given IMB is setting the paper? Okay, so Anshrita, I'll talk about this in a few moments. Okay, I believe a lot of you would like to know this thing. Again, I'll not keep you in dark. I'll tell you whatever I know as per my experience of last 15 years. Okay, so I have seen every IIM setting the paper. Now, a lot of us have a misconception that if IIM Bangalore is setting the paper will be difficult, or verbal section will be difficult, QA will be easy or difficult. I don't know what all misconceptions, what all things we have in our mind. Okay, but as far as my experience is concerned, I have never given a weightage to the IIM who is setting the paper, to this fact that which IIM is setting the paper. All right. Now, it does not depend, because obviously the professor of IIM will not make CAT paper. So there is a separate authority who sets the examination of CAT every year. All right. They just give their requirement about the level of difficulty of different sections. And it depends not on the IIMs, but it depends on the requirement of the industry. All right. So if some, like in some year, let's say the requirement of the industry is they want more number of engineers, then the paper will be inclined towards maths. If they want more number of students from arts or commerce background, they don't want engineers, then the paper will be a little difficult from verbal side. All right. So it is the industry's requirement. It is not like decided by which IIM is setting the paper. This is what my experience says. Okay, so let us continue and look at the next thing. Okay, now next is circumcenter. Circumcenter is the center of a circumcircle. Okay, circumcircle is a circle that is passing through all the three vertices of a triangle. All right, now moving and looking at what circumcircle is. So definitely it is made by the intersection of perpendicular bisectors. The way in center was the intersection of angle bisectors, this is the intersection of perpendicular bisectors. Now to obtain the circumradius, the radius of this circle, which is denoted by capital R, you can use the formula ABC upon 4 capital A. A, B and C are the sides and capital A is the area. So this is how you can get capital R, which is circumradius, or this can be used as another formula, the last formula of the area of triangle, which is ABC upon 4 capital R. So area of a triangle in terms of capital R, the circumradius. All right. So this is again one of the most important formulas that you can keep in mind for your CAT preparation. Now next, last geometric center, that is orthocenter. Orthocenter is the intersection point of the altitudes. Altitude, from a vertex, a perpendicular is dropped on the opposite side. That is called an altitude. Okay, so intersection point of all the altitudes, right? So this is how you can obtain the orthocenter, by dropping the altitudes from all the three vertices of the triangle on the opposite sides. All right. Now, some of the properties of chords related to a circle. Next thing. So that was triangles we have done. Now let us look at some of the formulas, some of the properties in circles. The first set of properties related to chords. Property number 1, the perpendicular distance from the center to a chord will bisect it and vice versa. Okay, so we can say that perpendicular dropped from the center of the circle to the chord will bisect the chord, and the point or the line joining the center of the circle to the midpoint of the chord will be perpendicular to it. Okay, I'll repeat, the perpendicular dropped from the center of the circle to the chord will bisect the chord. All right, so this is the very first property. Second property is the angle subtended by a chord of a circle at the center is double the angle it subtends at the circumference. So let's say this is a circle. This property is very important. So let's say A and B are the 2 points. So you can look at arc AB or chord AB. Okay. Now the relation is between this angle and this angle. So if this angle at the circumference is 30 degrees, then what will be the measure of the angle at the center of the circle? The measure of the angle at the center of the circle will be double the measure of the angle at the circumference. So this angle will be 30, double of 30, that is 60. Okay, fine. Okay, so Jadev has given the answer. Obviously, the number of questions will be different. So how can you expect the same level of difficulty and the same type of questions? Definitely, there will be something different. It doesn't mean that in CAT 2016, if IIM Bangalore has set the paper, then they'll be giving you the same level of difficulty in this year as well. It is not necessary. Okay, it may be possible. It may be a coincidence, but not necessarily. All right. So let us not spend your energy in thinking about what will be the level of difficulty. Why can't we prepare well and take this examination? Is it so difficult? Why are we not focused in the preparation? Why are we focused on different threads, different talks that runs around the internet? These all things will waste your time. So please don't focus. Don't waste your energy in finding the answer to the questions which actually does not affect your preparation and your performance in CAT. All right. So spend your time in preparing and hence it will improve your performance in CAT. All the best. Okay, let's continue. Next property, the angle in a semicircle is always 90 degrees. Or you can say that angle subtended by a diameter. Let's say this is the diameter passing through the center. So what will be the measure of this angle? The angle made by the diameter on the circle, this angle will always be 90 degrees. Okay. Varun is asking, sir, is IMS mocks also helpful apart from BYJU'S? Will it meet the actual level of CAT? Varun, thing is, if you are looking at the mock test series, it will be fine if you stick to one test series. All right. But if you have time to prepare or time to take some more mock papers, then test series of any institute will be fine. Okay. Moving ahead, next property, the angle inscribed by the same arc is always equal. So if you will consider an arc on the same side of the circle, if you will draw different angles, then the measure of all these angles will be equal. So this angle and this angle, all of them will be equal. So angle subtended by the same arc on the same side of the circle will always be equal. Okay. All right. Now next is two chords of a circle which are intersecting at a point P. I'll draw this figure. So if I draw two chords which are intersecting inside the circle, chord AB and chord CD, let's say intersecting at any random point P. So you can say that PA into PB will be equal to PC into PD. The same thing will happen if the chords are meeting outside the circle. Okay. So if they are meeting outside the circle, chord AB and chord CD, when extended meets at point P, the same property will be true. PA into PB will be equal to PC into PD. Right? Now, a few more properties and then we'll look at the questions. Now, opposite angles of a cyclic quadrilateral are supplementary. Cyclic quadrilateral hota kya hai? Cyclic quadrilateral is a quadrilateral such that all the four vertices will lie on the circle. In the cyclic quadrilateral, the sum of opposite angles is always equal to 180 degrees. All right. Move ahead. Circle's next property, tangent and secant. So in a circle, if I draw a tangent and a secant, so from an external point, if we draw two tangents to a circle, the length of these two tangents will be equal. So from an outside point, two tangents can be drawn to a circle and their length will be equal. Now this is one property that we'll be using today in one of the questions. Okay, so remember this property. From an outside point, tangents drawn to a circle are equal. Right? Now if a straight line is drawn as a tangent to a circle, the radius drawn to the point of contact will be perpendicular to the tangent. So this is called the point of contact, point of tangency. From the center, if the radius is drawn, this is perpendicular. So the tangent and radius are perpendicular to each other at the point of tangency. Okay? Right. Let's move ahead and look at the next property, alternate segment theorem. Now this is a wonderful theorem to understand. Okay. So I'll draw the figure step by step. Circle is drawn, a tangent is drawn. At this point of tangency, a chord is drawn, let's say R. Okay. Now, this angle which is theta between the chord and the tangent is equal to angle made by the same chord in the opposite side of the circle. So this angle, so this will also be theta. As you can see in this figure, theta and theta, alternate segment theorem. Now you must spend 5 minutes on this theorem, practice 3 or 4 questions related to that. This is a very important theorem as far as circles is concerned. Okay. All right. Now moving ahead, properties of tangent and secant. So from a same point, a tangent and a secant is drawn. So you can say that PA into PB is equal to PT square. Okay. All right. So that is all about the concepts, and let's come to the point, all of you, the moment for which you were waiting for. Let's practice some questions. All right. So again, come on, give me an acknowledgement and show that you all are present in the session. Come on, all of you. So far we are going good. Yes. So show me your presence, all of you, by writing yes, by acknowledging that you are present in this session. Come on. All right, lovely. Joydeep, you're asking, can I crack CAT in 30 days? I have been preparing for 3 months and my score is around 50 to 60 percentile. Now, Joydeep, if you will practice continuously for the next 30 days, then definitely can increase your percentile to a certain level. 80 to 90 percentile, till 80 to 90 percentile, yes, you can increase. All right. Okay. Now, all of you be ready with the first question on your screen. It will be there in a few moments. Be prepared with your rough sheets and a pen. All right. Okay. The first question. Two sides of a triangle are 8 centimeter and 15 centimeter. The triangle has integral sides. Answer the following questions. Question number 1. How many triangles are possible? So two sides of the triangle are already given, 8 and 15, and the triangle has integral sides. You have to find out the total number of triangles which are possible. Second question, how many right angle triangles are possible? Third question, how many obtuse angle triangles are possible? Fourth is how many acute angle triangles are possible. But before that, we'll look at the first question, how many triangles in total are possible. Okay. Anyone? The answer for the first question, and then I'll bifurcate the total number of triangles in right angle, obtuse angle, and acute angle triangles. Now we can use the property that sum of the lengths of any two sides will always be greater than the third side. So A plus B will always be greater than C. Okay, you can use this property. Or you can say that the third side, let's say C, will always lie between the difference and the sum of the two sides. Okay, I'm writing the modulus just to make sure that it will be a positive sign. Okay, now what is the difference of these two sides? 15 and 8 ka difference has 7. So the third side will be greater than 7 and it will be less than the sum of these two. 8 plus 15 is 23. Okay, so it will be strictly greater than 7 and less than 23. So starting from 8, 9, 10 and so on up till 22, these can be the possible values of the length of the third side. So starting from 8 up till 22, you can just count these numbers on your fingers. So it will be equal to 15. So there are 15 possible triangles with two sides as 8 and 15. So some of the students have correctly given the answer. Some of you have given 16 as the answer. Starting from 8 up till 22, there are 15 numbers. Okay, so yes, the answer is 15. Now let's look at the answer for the second question. So second question is, how many right angled triangles are possible? Now for a right angle triangle, we can say that a square plus b square is equal to c square. Okay, it should satisfy Pythagoras theorem. Now out of 8, 15, and let's say the third side is x, which one of the three sides will be hypotenuse? Now obviously the largest side is hypotenuse, so 8 cannot be the hypotenuse. Okay, so either 15 can be the hypotenuse or x can be the hypotenuse. So I'll make two cases. Case number 1, if 15 is the hypotenuse, so 8 square plus x square is equal to 15 square. Okay, if 15 is the hypotenuse, I'll write it once again. 8 square plus x square equals 15 square. Now from here, the value of x will come out to be 15 square, that is 225 minus 84. 225 minus 64, I'm sorry, that is 161, under root of 161, which is not an integer. So 15 cannot be the hypotenuse. Second case, 8 square plus 15 square is equal to x square. X can be the hypotenuse. And we already know a Pythagorean triplet 8, 15, 17 related to this. So definitely the value of x will come out to be an integer that is equal to 17. And yes, we have only one right angled triangle. All right. So up till this point, most of you have given a correct answer. So only one right angled triangle is possible. So out of 15 total triangles, we have one right angled triangles. Now the remaining 14, how they can be divided among obtuse and acute angled triangle? This is the next question. Okay, so I'll erase whatever is there on the screen. Now I have 15 total triangles, out of which one is right angled triangle. And now let's talk about acute and obtuse angled triangles. Okay, so 8, 15, and x, these are the three sides. All right. Now for an acute angled triangle, I can say that a square plus b square is greater than c square. For obtuse angled triangle, a square plus b square is less than c square. All right. In both the cases, c should be the largest side of the triangle. All right. Now I have these three sides of the triangle. Obviously 8 cannot be the largest side. So again, I have to consider either 15 or x as the largest side, and we'll check for acute angle triangle property. Okay. So if I'll consider 15 as the largest side, 1 17 cannot be the answer because 15 is the total number of triangles possible. So if I'll consider 15 as the largest side, so I can say that 8 square plus x square should be greater than 15 square. So x square should be greater than 15 square, that is 225. I'll write it directly, 225. Okay, so 225 minus 64. So that means x is greater than under root of 161. That means x is greater than 12 point something. Okay, 161 का under root क्या होगा? It will be less than 13, more than 12. So x will be greater than 12. All right. Okay. Now this is the first case. Second case, if I'll consider x as the greatest side. So I'm sorry. If I'll consider x as the greatest side, then I can say that the sum of the squares of the two other sides should be greater than the largest side ka square. Okay. So 8 square plus 15 square should be greater than x square. Now 8 square plus 15 square is greater than x square. So x square should be less than 8 square, that is 64 plus 225. So x is less than under root of 289. That means x is less than 17. Okay. Now x is less than 17 and x is greater than 12 point something. So the values of x can be 13, 14, 15, 16. All right. 13, 14, 15, 16, less than 17, right? So these are the four possible values of x for which the triangle will be an acute angled triangle. All right, fine. Amrit, it will be 4 for acute angled triangle. So there will be 4 triangles which will be acute, and the remaining 10 triangles will be obtuse angled triangle. Am I clear to each and everyone? How have I calculated this thing? Yes or no? Akhil and education word, I believe you both have understood a very basic mistake, very small mistake probably you would have done in counting these triangles. So both of you were very clear. No requirement to remove your answers is absolutely fine, guys. We are at a learning stage. Okay. So even if we have given wrong answers, the most important fact that I appreciate is you have given the answers. Okay. So just show to the world that you have given the answers. You were not sitting idly. Your answers were very close. Your answers were the closest among the answers that people have given. All right, fine. So keep it up. Don't afraid of giving wrong answers. I appreciate the gesture of the students, those who have given the answers. All right, let's move ahead and look at the next question. Question number 2 on your screen now. So Akhil, now you know what things you need to consider to take care in the examination. All the best for the next questions. In the following diagram, O is the center of the circle. QR is parallel to the diameter. So O is the center of the circle. PS will be the diameter. QR is parallel to the diameter. And angle RSP, this angle is 60 degrees. And the radius is 8 centimeters. Find the area of the quadrilateral PQRS. Gibson, how did I get 10 in obtuse? So Gibson, total were 15. 1 was right angle, 4 were acute angle. So subtract these from the total. Okay. Now all of you can look at this question properly. This will take some efforts. A wonderful question this is. Now can you tell me what is this quadrilateral? What is this specific type of quadrilateral? Do you have any specific name that I can give to this quadrilateral PQRS? Anyone? Any specific name to this quadrilateral PQRS? If you can do that, probably you will be able to find the area of this quadrilateral easily. Saideep, yes, cyclic, fine. You can call it cyclic, but important, more important than cyclic quadrilateral, music core has given the answer. This is a trapezium. Guys, this is a trapezium. In a trapezium, opposite sides, one pair of opposite sides is parallel and the other pair of sides is non-parallel. So I can say that PQRS is a trapezium. So if you'll think about a trapezium, area of trapezium, which is half into sum of opposite sides, sum of parallel sides multiplied by height. All right. So this is the area of trapezium. You know the value of PS, you know the length of PS, radius is given. You can find the length of QR as well as the height of this quadrilateral. And hence you'll be able to find out the area of this quadrilateral. Let's continue. Let's start with this. Okay. Now, first of all, this angle is given as 60 degrees. What I'll do is I'll drop a perpendicular from point R. Let's say this point is T. Okay. This is perpendicular. 60 and this is 30. All right, fine. I have dropped a perpendicular. Okay. Now length of PS. So I'll erase this first of all. So this is a 60 degree. Length of PS is given as 16 because radius of the circle is 8 centimeters. So I can say that diameter will be 16. Now first of all, consider triangle PRS. I can say that this triangle is 30, 60, 90 degree triangle. The ratio of the sides will be 1 is to root 3 is to 2. Now, PS, which is the largest side, which is opposite to 90 degree, is given as 16. Okay, 16 is given. So I can say that side which is opposite to 60 degrees multiply by 8 ho raha hai, so this will be 8 root 3 and the smallest side will be 8. Okay, so length of RS will be equal to 8 and length of RS will be equal to 8 and length of RP will be equal to 8 root 3. This is the first step. Akhil has already given the answer. Good, Akhil. Nice. Okay. So, not only finding this answer is important, looking at different concepts is also important. Okay. So, I'm looking at that. Now, I'm dropping a perpendicular. Let's say this is T. Okay. Now, again, consider this entire triangle. I can say that the area of this triangle can be written by two different ways. Half into RS into RP, or you can write it as half into PS into RT. Okay, so both the areas will be equal, right? So you can say that the value of RT will be equal to RS into RP divided by PS, which is a standard result for a right angle triangle. Okay, this is equal to 8 into 8 root 3 divided by 16, that is equal to 4 root 3. Okay, so height is 4 under root 3, right? This is first part. Base, the value of ST will be equal to 4. ST will be equal to 4. Again, if I drop a perpendicular from here, P, isko bol dete hain A. PA will also be equal to 4. So if PA is equal to 4 and ST is equal to 4 out of a total 16, then AT will be equal to 8. AT and QR will be equal. So length of QR will also be equal to 8. All right. So in this, QR is equal to 8. PS is equal to 16 and the height RT of this trapezium is equal to 4 under root 3. Now you can find out the area of this trapezium using these three. Half sum of parallel sides 8 plus 16, that is 24, multiplied by the height, that is 4 root 3, and the answer will be 48 root 3. So yes, 48 root 3 will be the area of this quadrilateral. All right, or I can say trapezium. So the correct answer, yes, it is option C. Okay. All right. Now let's go ahead and look at next question, question number 3. A very interesting question. A very interesting question, and wonderful shortcuts will be used to find the area or to find whatever is asked in this question. So in a triangle ABC, draw the figure properly. Okay. In the triangle ABC, D bisects BC, G bisects AB, and the points E and F, they will trisect AC. What is the area of the polygon AGEFD? Sorry, what is the area of polygon BGEFD if the area of the entire triangle is given as 108 square units? A wonderful question. Let's draw the figures simultaneously. I'm doing it slowly. All of you can do it quickly. Now D bisects BC. So this is point D. BD and CD are equal. G bisects AB, midpoint of AB, and points E and F trisects. That means divides AC in 3 equal parts. Okay. Now what is the area of polygon BGEFD in square units if the area of triangle ABC is 108 square units? Okay. Now we need to find BGEFD. All right. You all have understood which area do we have to find out? Okay. So I'll join this as well. So that means we have to find this shaded area. So from the total area 108, if I'll subtract area number 1 and area number 2, I will get the answer. Alright, okay. Now what I'll do here, first of all, I'll explain you the concept that I'm going to use here. So I'll go back to the previous screen where I'll draw a separate figure to make you understand the concept. Okay. Now let's say this is triangle ABC. Now this is the midpoint G and this is point of transection E and F. Okay. Now using the formula of the triangle, of the area of the triangle, half product of two sides into sine of containing angle. Okay, I'll be using this formula. Now I'll consider this as x, x, y, y and y. Okay, and consider angle A. So I can say that area of this triangle can be written as half AB into AC sine of angle A. Okay, now half AB is 2x, AC is 3y, sine of angle A, right? Now similarly, let's say I have to find out its ratio with this triangle. Okay, so the second triangle which I have marked, its area will be half into x into y sine of angle A. Sine A is common, half is common, x will get cancelled, y will get cancelled. So the ratio will come out to be 6/1. Okay, the ratio will be 6/1. So you can use the common angle between the sides and look at the lengths of the portion of the sides to calculate the ratio of the area. Okay, so going back to our original question, area of the first region, if I'll say that this is x, x, y, 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 z and z. Okay, so area of 1 upon total area of the triangle, इनका ratio क्या होगा? It will be, so smaller triangle sides हैं x and y. Okay, so x and y are the sides. Half will be common, sine A will be common. I'm not writing the common things. And for the bigger area, it is 2x and 3y. So the ratio will be 1/6. So A1 will be equal to 108 divided by 6. 108 divided by 6. Alright. So it will be equal to 18. So area of the first region will be equal to 18. Let's look at the area of second region. In the similar manner, it will be equal to 18. Okay, so A2 will also be equal to 18, right? So out of 108, you can subtract 18 and 18 and the answer will be equal to 72. So the area of the required portion, yes, it is equal to 72. Okay, all right, let's move on to the next question. Question number 4. Find the length of the belt required to bind two circles with a radius of 24 and 30 centimeters such that a part of the belt becomes transverse tangent to the circles. Careful, it is not the direct common tangent, it is becoming transverse common tangent. So the belts will cross each other. Okay. So find the length of the belt required to bind two circles of radius 24 and 30 centimeters such that a part of the belt becomes transverse tangent to the circles with an angle of intersection of 60 degrees. It is very important to understand the figure. Okay. So first of all, let us understand the figure. Now the smaller circle and the bigger circle. Okay. Now the belt, I'm using the red color pen. So you can see that the belt will be like this around the circle and like this. So this is how the belt will be. Pardon my drawing. Okay. So this is how the belt will be. Okay. So I'll draw another figure properly. So this is one circle, the smaller of the two circles, and this is the bigger circle. Okay. We have to find out this part and this part and the length of the entire belt. Okay, so let's say this is point A, this is point B, point C and point D. Okay, center of the circle O and P. Now the angle of intersection is given as 60 degrees. So this is 60 degrees. Okay, let me call this point as R. I hope all of you are clear with the figure. Okay, so what do we have to find? First of all, we have to find RC plus RD. So RC and RD, they will be equal. We have to find RA and RB. Both of them will be equal. And then we'll have to find out the entire arc CD. So the major arc CD and major arc AB. So plus major arc CD and plus major arc AB. Okay, so this will be the entire length of the belt that we are looking for. Fine. Now this angle is 60 degree, that is in front of us. If I'll join these two with P, they will be 90 degrees. All right, they will be 90 degrees. And let's join CD as well. Now consider triangle RCD. Can you tell me which type of triangle will it be? Triangle RCD. This will be an equilateral triangle. Okay, ये एक equilateral triangle होगा. Okay. Now length of PC, that is the radius of this circle, is given as 30 centimeters. Okay. Using this, I'll be able to find out the length of RC. So I'll join this part. Okay. So this angle. So let me draw this triangle separately so that all of you can visualize it. P, C and R. This is 30 degrees. Okay. Sorry, this is length 30. This angle is 30. This is 90 degree and this is 60. Okay. Clear? So from here I can find the length of RC. So RC की length find out कर लेते हैं. So this is opposite to 30 degree. Okay. So this will be equal to 30 root 3. So RC will be equal to 30 root 3. So does RD. Similarly, I can find RA and RB, which will be equal to 24 root 3 each of them. Okay. Up to this point, I believe it is clear. So RC plus RD, 30 plus 30, that is 60 root 3, and 24 plus 24, that is 48 root 3. So total 60 and 48. 30 root 3 multiplied by 2 plus 24 root 3 multiplied by 2. Up till this point, this has become 108 root 3. Okay, so 108 root 3 is the sum of these transverse common tangents. All right, 108 root 3 plus something will be the answer. Now among the option, you have only one option in which you have 108 root 3. You can mark this option as the answer. But I would like to complete this question. Okay. Now looking at this angle. So this angle will be equal to 120 degrees. Complete quadrilateral consider kar sakte ho. Two angles are 90, one is 60 degree. So this angle is 120. So the remaining part of the angle will be equal to 240 degrees. Okay, so we have to find out the length of the arc which is subtending an angle of 240. So length of the arc is given by theta upon 360 degree into 2 pi r. R is 30 degree in this case. R is 30 centimeters in this case. Okay, so 60 pi into 2 by 3. So that will be equal to 40 pi. So 40 pi will be the length of the arc in the first case. Okay. Now let's look at the second case. Second case, again the same formula, theta upon 360 degree into 2 pi into 24. 24 is the radius of the first circle. Okay. So 48 into 2 by 3, that will be 32 pi. So 32 pi and 40 pi, that will sum up and will give you 72 pi. So 72 pi plus 108 root 3 will be the final answer for this entire question. Okay. All right. Now the questions that we are doing, these questions can easily qualify for the questions in your actual CAT examination. Okay. So look at or understand how quickly I'm calculating these numbers, how quickly I'm calculating these values. Okay, let's move ahead and look at our next question. Again, a wonderful question. In the given figure, PQRS, if you can find PQRS in the figure, PQRS is a square. The sides are extended to T, OT, M and N such that OP is to PQ. Okay, so OP is to PQ is 1 is to 2. So if this is X, this is 2X. RM is to RS, this is X and this is 2X. Okay. Now, secondly, this ratio NQ is to QR is 3 is to 2. So if this is again 2X because it was a square, this will be 3X and 2X and 3X. I hope all of you are clear about the values in terms of X that I have written. Okay. Ab question bahut easy hai. All of you can do it. If the area of the quadrilateral MNOT, if the area of MNOT, that means this entire figure is 126 square units. What is the area of PQRS? Okay. Now let's write each of these areas in terms of X. Okay. So let me take another color which will be visible properly. Okay. So this color is visible. Yes. Okay. Now, first of all, area of this triangle on the left hand side, half into base into height. This is what I'm going to use. So 5 and X. So 2.5X will be the area of this figure. Similarly, this figure 2.5X. Next, ऊपर वाला जो triangle है, so 3 and 3, 9, 4.5X and 4.5X. And the square will have area, sorry, X square hona chahiye har jagah pe. Okay. And the square will have area of 4X square. So in terms of X, the entire area will be 4 plus 5, that is 9, and 9, 18. So 18X square is equal to 126. This is given to us. Then the area of the square PQRS, that means we have to find 4X square. I hope all of you will be able to do this thing easily. Okay, so 4X square will be equal to 126 divided by 18 multiplied by 4. Let's do the calculations. So the answer should be equal to 28. And yes, Akhil is the first person who has given a correct answer. All right, fine. So this one was easy. Figure thoda sa ajeeb lag raha tha, difficult lag raha tha, but the question was simple if done in this manner. Right? Okay, so the answer for this question, yes, it was 28. Let's quickly move on to question number 6. In the following figure, the radii of the largest and the smallest circles are 32 and 8 respectively. Carefully find the length of BD. Now, before you get me the length of BD, first of all, you are given the largest as R1 as 32 and R3 as 8. So can you, using these two, give me the value of R2? First of all, I want the value of R2 from each and every one of you. How to directly find this thing? Now, there is a concept. In such a kind of figure, if the circles are touching each other and the common tangents are drawn, okay, like this. So if you have this type of figure, then you can say that these circles will have their radius in geometric progression. So R1, R2 and R3 will be in GP. So you can say that the value of R2 will be equal to under root of 8 multiplied by 32. And yes, that is equal to Yes, anyone. That is equal to 16. So Akhil, good yaar, good, nice. So Akhil remembers a lot of concepts. Impressive Akhil, good, keep it up. So the value of R2 will be equal to 16. Okay. So R1, R2, R3, R4, kitne bhi circles hain, whatever be the number of circles, their radius will always be in geometric progression. Okay. So first thing we have already determined that the value of R2 will be equal to 16. Okay. Now let's use similar triangles to uh, like evaluate or to get the values of other things. Okay. Now DO3 upon DO2 will be equal to CO3. CO3 लिखने की जरूरत नहीं है, R3 लिख देता हूं मैं. ठीक है. So using similar triangles, DO3 upon DO2 will be equal to R3 upon R2. Alright. Now DO3 इसको हम ऐसे ही छोड़ देते हैं. DO3 divided by DO2 can be written as DO3 plus R3 plus R2. R3 plus R2. ठीक है. R3 plus R2 कितना है? 8 plus 16. That will be equal to 8 upon 16. So from here you can find the length of DO3. Okay. So that is equal to 1 upon 2. So DO3 will be equal to 6 plus 8, that is 24. Now DO3 का वैल्यू पता लग गया 24. So DO2 का वैल्यू पता लग जाएगा, that is 24 plus 24, which is 48. Okay. Now we need the value of BD. So BD will be equal to under root of DO2 square minus R2 square. So basically this is forming a right angle triangle, right angled at angle B. Okay. So from here get the length of BD. So that is 48 square minus 16 square. Take 16 common and it will be 3 square minus 1 square. That is 16 under root 8, or you can say that 32 root 2. So 32 root 2 will be your final answer. Right? Simple question tha again. Not a very difficult concept. Just to save your time, you need to know that R1, R2, R3 will be in geometric progression, and then rest it is similar triangles and right angle triangles. So the answer for this question will be option B, that is 32 root 2. Let's move on to the next question, question number 7. Now the logic that will be used in this question we have already covered in today's lecture. So I want each and everyone to quickly give me an answer for this one. Consider triangle ABC that is drawn in front of you. D, E and F are points taken on these sides such that the angle AFD is equal to angle CFE. Some angles are given equal. Okay, so this is wonderful question, I can see. So angle AFD, this angle, and CFE, these angles. So these two angles are equal. Okay. Now angle ADF, this angle that I've marked and this angle that I'm marking now are equal, and further this angle and this angle are equal. Okay. Let's see how many of you can give me an answer for this question. If the ratio of BE, EF, FA and AB is 2, 3, 4, 7, find the ratio of the areas of triangle ABC and DEF. A lovely question for all of you. Any answer? Okay, let me start with this one. So these two angles at the bottom around F are equal, so I can consider them as angle A. Another two angles are equal, angle B, and these are angle C. Okay, so AA, BB and CC are the angles that I have considered. Okay. Okay, now what else? After this, what can be done? What about the remaining angle in all of these triangles? What about the remaining angles? Yes, anyone? चलिए check करते हैं. Now consider the innermost triangle, triangle DEF. So triangle DEF, this has three interior angles. The sum of the three interior angles of DEF should be 180 degrees. I'm writing angle F. So triangle DEF is what I'm considering. So angle F will be 180 minus twice of angle A. Okay. Then angle D is 180 minus twice of angle B. And similarly, the third angle 180 minus twice of angle C. And the sum of these three interior angles should be equal to 180 degrees. Now this gives me 2A plus 2B plus 2C as 360 degrees, or A plus B plus C as 180 degrees. Okay, so A plus B plus C will be 180 degrees. Now look at each of these smaller triangles. Look at the triangle on the rightmost side, ADF. Now ADF में दो angles A और B हैं. The third angle should be equal to angle C. Yes, because A plus B plus C is 180, right? Similarly, in the above triangle BED, two angles are B and C. So the third angle has to be angle A. And similarly here on the left hand side, the third angle has to be angle B. Okay, so now you can say that all the triangles that you can see in this figure are similar, and they all will be similar to the bigger triangle, the biggest triangle that you can see, the triangle ABC. Okay, now the ratio of the sides, BE is 2x, EF is 3x, FA is 4x, and AB is 7x. These are some ratios which are given. Okay, now look at triangle number 1, then triangle number 2, then triangle number 3, and then the biggest triangle. Okay, in triangle number 1, you are given this side which is opposite to angle B. Okay, in triangle number 2, again you are given this side which is opposite to angle B. In every case, you are given the side which is opposite to angle B. Okay, so I can say that area of triangle 1 is to area of triangle 2 is to area of triangle 3 is to the area of triangle, the biggest triangle. I'm writing it as capital A, triangle ABC. Now these will be in the ratio. These ratios will be the square of the ratio of their sides. So that means 2 square is to 3 square is to 4 square is to 7 square. Okay, so I can say that the ratio will be 4 is to 9 is to 16 is to 49. This will be the ratio of first triangle, second triangle, third triangle, and the biggest triangle. Okay, now I want triangle ABC. I can write its area as 49x, that is this part, upon triangle DEF. So for DEF, what you can do is, from the biggest area 49x, you can subtract the other three areas 4, 9 and 16. So 4x, 9x and 16x subtract kar do. So you will get the ratio 49x divided by 29, that is 20x. So the ratio will be 49 upon 20. And 49 upon 20, the answer is option A. Akhil and Shweta Singh both have given the same answer. Okay, all right. So the answer for this question will be 49 is to 20. Done? Okay, Now let's move towards our next question, the last question for the day. Okay, I understand it's already been 1.5 hours, one of the biggest session that you would have attended on our YouTube channel. Now question is, find the maximum distance of this point from the circumference of the circle whose equation is this. The maximum distance of this point from any point on the circumference of the circle. Okay, so you can say that if this is the circle, point is here, so distance can also be this, distance can also be the shortest. You have to find the maximum distance. That means you'll have to consider this point on the opposite side on the circumference. Okay, I have given you a hint. This is a question on coordinate geometry. I'm expecting a good answer, a correct answer from each and every one of you. I'll start by writing the general form of the equation of a circle. X square plus y square plus 2gx plus 2fy plus c equal to 0. The center is denoted by minus g comma minus f, and the radius is denoted by under root of g square plus f square minus c. So I'll write both these things, minus g comma minus f after comparing. So the value of g is 2. So center is minus 2, comma, the value of f is minus 3. So it is 3. So minus g comma minus f will be the center. Radius is 2 square, that is 4 plus 9, minus of minus 12, that is plus 12, and that will come out to be 5. Okay, so radius is 5. Now the concept that I'll be using here is, obviously this point is outside the circle, let's say somewhere here. So what I'll do is, I'll find the distance between this point, that is 4 comma minus 5, and the center of the circle minus 2 comma 3. I'll find this distance and will add the radius to this value. That will give me the maximum distance between the point and the circumference. Okay, so using the distance formula, first of all, distance between this outside point and the center of the circle, 4 minus minus 2, that is 6 square, plus minus 5 and 3 may difference 8 square. So this value will come out to be 10. So the distance between this point and the center of the circle is 10. And in this, if I'll add the radius of the circle, you will get the maximum distance between the point and the circumference of the circle. So Akhil, wonderful to see the efforts from your side. I believe you are well prepared for CAT. All the best to all of you. This is the correct answer for this question. All right. Okay, so 15 is yes, definitely the correct answer for this one. All right, friends. So that was the last question of the day, and we'll stop here and I'll tell you the schedule of the upcoming sessions. So this is brief schedule for the next 5 sessions. You can note down. Now tomorrow you can see me once again with some of the wonderful questions on Venn diagrams. 28th you will see Savitri ma'am with getting parajumbles right. Then Saral sir, how to get all number system questions correct. And then 2 sessions of Nikita ma'am will follow on reading comprehension and spotting the odd one out. So this is the schedule for our next 5 sessions. I hope all of you would have liked this session and enjoyed this session. Don't forget to join us for detailed CAT analysis on 27th of October. You know that obviously we will be coming in front of all of you with the detailed analysis of CAT 2022, the slot-wise detailed analysis of CAT 2022 on November 27th. All the best to all of you. Anyone who is taking examinations this year, one important thing for all of you is an all India open mock. It will be live from 20th of October up till 6th of November. Must take this mock test in order to analyze your strategy. Yes, education word tomorrow, 27th of October. Yes, admit cards you'll be getting, definitely. Okay. Now for CAT 2023 students, a comprehensive program is launched by us. You can enroll in this session. All the details are there on your screen. All the best to all of you. Thank you very much for being a part of this session. All the very best. We'll see you tomorrow at 7 o'clock with a session on Venn diagrams. Till then, have a nice day. Bye bye.